Hello everyone, this is John Porjong. Today we will study I2NSF registration interface young data model. This figure shows I2NSF framework and interfaces. Today we will study this interface, registration interface between developers management system, DMS, and security controller. So the upper one is I2NSF user, license side I2NSF analyzer, bottom there are network security functions, NSFs. I2NSF registration interface young data model. This is specified the data internet draft ITF I2NSF registration interface data model DM version 26. You can click this link, you can reach this document. So introduction to registration interface young data model. So this document defines an information model and young data model for the registration interface between security controller and developers management system called the DMS. In I2NSF framework to register NSF network security functions of DMS with security controller. So NSFs produced by multiple security vendors provide the various security capabilities to customers. So since each of these NSFs likely has different security capabilities from each other, it is important to register the security capabilities of NSFs to the security controller, network management operator system. Okay. In addition, it is required to search NSFs of some required security capabilities on demand. As an example, if additional security capabilities are required to solve some security service request from an I2NSF user, the security controller should be able to request the DMS for NSFs that has the required security capability, which means so we need to support two things. One is some registration of NSFs with security controller. Also, the other one is the search or query to find the appropriate NSFs to satisfy required security functions. So we have three objectives here. First one is registering NSF with I2NSF framework. The second one is updating the capabilities of registered NSFs. The last one, third one is asking. It is called calling DMS about some required capabilities. So the first objective, registering NSFs, DMS in I2NSF framework is typically run by an NSF vendor and uses a registration interface to provide the NSF information such as capability, specification, and the access information developed by the NSF vendor to a security controller. Since there may be multiple vendors for these kinds of security services that provide the NSFs for a target network, the I2NSF registration interface can be used as a standard interface for the DMSs to provide NSFs capability information to the security controller. For the registered NSFs, security controller maintains a catalog of the capability of those NSF to select the appropriate NSF for the requested security services. The second objective is updating the capabilities of registered NSFs. After an NSF is registered with security controller, some modifications on the capability of the NSF may be required later. In this case, DMS, Developer Management System, uses restoration interface to deliver the update of the capability of the NSF to the security controller. And this update must be reflected on the catalog of NSFs existing in the security controller. That is, DMS sends the updated NSF capability information to the security controller through a notification mechanism. Finally, security controller updates its catalog of NSFs with the updated NSF capability information. The third one, objectives, asking DMS about some required capabilities. So when high-level policy delivered from I2NSF user over consumer-facing interface to security controller, so translator tried to translate high-level policy into low-level policy. If there is no such NSF to certify or enforce that requested security function, this query or asking is used. In the cases that some security capabilities are required to solve the security service request from an I2NSF user, the security controller searches through the registered NSFs from NSF database to find the ones that can provide the required capabilities. But security controller might fail to find any NSFs having the required capabilities among the registered NSFs. In this case, the security controller needs to request the DMS for additional NSFs information that can provide the required security capabilities via registration interface. So we have design principles. The I2NSF registration interface is used by security controller and developers management system, also known as DMS, in I2NSF framework. I2NSF registration interface consists of two sub-models. The first one is NSF capability registration. Second one is NSF capability update. Each sub-model is used for the operations listed above. The remainder of the slides will provide in-depth explanation of each sub-model. This NSF capability registration sub-model. So this sub-model is used by the DMS to register the capabilities of NSFs with the security controller. So basically here, NSF registration, capability registration here, consists of NSF name and NSF capability information and NSF access information. So this is just the NSF's name. This is a canonical name, host name over DNS name, and NSF capability name contains actual capabilities, and access information is NSF IP address and port number, like a TCP port number, and actual management protocol like a netconf or lastconf. Okay. So here, NSF capability information here, NSF capability information here. So consists of I2NSF capabilities and the NSF specification. So I2NSF capabilities case, directional capabilities, event, condition, action capabilities are specified. And then similar level here, okay, and the resolution if there is some conflict of some event condition. So we have resolution strategy here, and also if there is no specified action, default action capability are specified. So NSF capability information basically describes security capability of NSF. So we saw this I2NSF capabilities. Okay. So NSF capability restoration, especially NSF capability information here. So this information represent the NSF specification information like packet processing and bandwidth. Okay. So packet processing, the overall capability of NSF in processing packets measured in packets per second (PPS). Bandwidth describes the information about available network amount in two cases, such as outbound and inbound bandwidth. And assuming the current throughput and packet rate statuses of each NSF are being collected through NSF monitoring interface. And these capabilities of the NSF can be used to determine whether the NSF in conjunction or not by comparing it with the current throughput of NSF. So this is the NSF specification. Okay, NSF kind of some kappa or capability. This is hardware, okay? Packet processing and bandwidth. And access information consists of IP address, version 4, version 6 address, and the port number. Usually TCP port number is used. And the management protocol netcomp or rescomp, okay? So in this document, NSF access information is used to identify a specific NSF instance, okay? So NSF access information is the signature. That is a unique identifier of an NSF instance in the overall I2NSF system. Okay. NSF access information. Deployed NSF may require to be updated to improve the quality of the security service, QoS. Security controller can request for the update of NSF to the DMS. In this case, security controller makes the description of NSFs to be updated by giving the name of the NSF and its current version. DMS can reply using the NSF capability information server model shown previous to slide 10 for updating the capabilities of the NSF. So this figure shows NSF capability restoration, the RPCs. So NSF capability restoration, input, query NSF capability. This is the NSF capabilities, and the output case about the query result. Okay, so this one is NSF name, version, directional capability, NSF capabilities, specification. And specification consists of packet processing and bandwidth, and then NSF access information here, IP port number and management protocol. So when a security controller requests security services to the DMS, DMS uses I2NSF capability Yang data model to describe what capability the NSF can offer. Security controller makes the description of the required capabilities and then queries the DMS about which NSFs can provide these capabilities. DMS includes the access information of NSF, which is required to make a network connection with the NSF, as well as the specification of the NSFs. So we saw access information consists of IP address, port number, and management protocol. Okay, so DMS can also include the resource management, resource information in terms of packet processing and bandwidth capability we saw previously. And the update operation started by the security controller subscribing for the notification of NSF's capability update. So you can report to RPC 8639. The title is a subscription to Yang notifications. And then some updates happen, and then DMS should only send the NSFs with updated capabilities. If an update is available, the DMS can deliver the NSF capability update and notification to the security controller. This young data model here, the update, NSF notification, NSF capability update. This is NSF name, version, capabilities, specification, and access information. So let's look at young module I2NSF registration interface. So reusable roles are specified. So using grouping. So NSF specification having packet processing and bandwidth. Okay, each one has the type here, unit specified here, and then bandwidth case outbound, inbound specified. Okay, separately. And the access information here, IP address, portal number, and the managed protocol case using enumeration type is used because netcomp or lesscomp is used. And NSF, okay, this grouping case, NSF name, version, and NSF capabilities. Also, it has specifications. Specification we saw previously, right? Packet NSF specification here, right? So we reuse, okay? Packet processing and bandwidth, okay? So we reuse. Use is means we reuse this container, and that it contains NS access information. Previous grouping is used. NS access information is used, okay? And then this node, NSF capability restoration, okay, using RPC, okay. So input and output specified, okay. So this node is used to complete the objectives 1 and 3. One is registering NSFs with the I2NSF framework. The third one is asking DMS, calling DMS about some required capabilities. It uses RPC statement here, NSF capability restoration, to allow operation definition. It has on input here, on input and on output, okay? On input for query of the NSF capability, okay? And then output is delivered by DMS, okay? Output is the list of NSFs that, okay, this is just one, delete, and cover every capability specified in the output field, okay? The input field cannot be covered by any NSF. The reply returns on RPC error. And this node is NSF capability update, okay? This is some notification, okay? So this is subscribed, okay, by security controller. So this node completes the objective 2 I2NSF registration interface. Objective 2 here, updating the capabilities of the NSF, okay? So it uses the notification statement here to allow notification definition. It provides the updates on the capability of one or more NSFs here, NSF here. And the list of NSFs provided in this notification includes the current capabilities post-update of each NSFs. So let's take a look examples of NSF restoration here. So this example shows the query for NSF with the following capabilities: IP version 4 source address, IP version 4 destination address, and URLs. And the NSFs also need to be able to drop ingress egress packet. So here the RPC, this message request, NSF capability restoration here. This is a namespace for I2NSF restoration interface. This is RPC, okay, netconf namespace. Query NSF capability condition, IP version 4, some source destination address, and this URL advanced NSF capabilities. This is inherit from I2NSF capability data YANG model. So this is user defined. And then action case, ingress, egress action, drop specified. So we have the general firewall capability, version 4 firewall. So the firewall, the name, version, and capability here. So condition capability is a generic. A generic capability usually L2, L3, L4. The header information is used. Have a field. So the IP version 4 capability. Next header protocol, source address, source IP address, destination IP address. This is TCP layer 4. TCP port number, destination port number. It can be used for fiber service. And then action case, yeah, pass, drop, mirror, ingress. Egress is pass, drop, mirror specified. And the NSF capability, actual hardware spec, is the packet processing capability here, and then bandwidth, outbound, inbound capability specified. Those kinds of firewall capability is registered with the security controller. And this one is the web filter. Okay, so we have two things: general firewall capability using this kind of thing, and also we can specify the IP address, access information, port number, managed protocol is netconf is used. Second, NSF capability, the web filter, URL filters. Okay, here. So similarly, the web filter case, the NSF name, the version number, conditional case, advanced NSF capability, especially URL filtering is specified. And the action capability, ingress, egress, three actions specified: pass, drop, or meter. And then NSF capability also packet processing, bandwidth, along with the outbound, inbound specified. And then NSF access information is specified. You can see IP address is, this is 192.0.2.11. This is a different IP address, 192.0.2.12. Okay, port number is the same for netconf. Okay, and then I specify this one, and then now we have the update. Okay, this is notification if there is a previous just reply something, and this is update case, some update here. So the NSF, the general firewall version is different, right? You can see version is different. This is a UDP capability added. Previously there is no UDP. Okay, UDP capability is added. So the version is update to 2.0.0, and capabilities are extended with the UDP capability like this. This is updated version. It can inspect the source and destination port number of UDP packets and the flows. In conclusion, today we studied the I2NSF reference interface YANG data model to specify the information and data models for the communication between security controller and developers management system, also known as DMS. This data model utilizes I2NSF capability YANG data model to specify capability of NSFs. The data YANG model provides two mechanisms, such as NSF capability restoration and NSF capability update. The NSF capability restoration is done with the RPC statement, while the NSF capability update is done with the notification statement. Finally, in this class, the usage of I2NSF restoration interface YANG data model is shown with examples such as firewall and web filter. Thank you for your attention. If you have a question, please let me know. Thank you.